We'll be working with matplotlib again in this video, continuing to explore that World Bank dataset that we started with. So by the end of this video, you should be able to create line charts and scatter plots using matplotlib. So a question I had about the data will allow us to explore using line plots and scatter plots. We saw that CO2 emissions per capita in the US went up in the 1960s, and then with some minor variance has remained pretty steady since. I'm curious how that relates to the US economy, specifically the US's GDP per capita. So let's set up similar masks as in the last video to pull out the GDP per capita for the USA over time. And then what we'll do is we'll check what this output is by running the head method. Looks like we have the data we want. Per year, we have the GDP per capita based on the value of US dollars in 2005. So this is pretty similar to what we had for CO2 emissions per capita. All right, before we plot these against each other, let's first take a look at the trend in GDP per capita for the US. I'll use a line plot for that. For the most part, we're seeing solid growth over time. There are a couple of dips here and there, and one noticeable dip in the recession around 2008. But the upward trend is restored by 2010. So knowing that CO2 emissions over that same time period didn't behave the same way leads me to think that they aren't closely related. But let's look at a scatter plot to see. So first, I'm going to need to make sure the time frames are the same by calling min and max in these columns. And the reason I want to make sure that these are the same is that scatter plots require the same number of years in the data set. Ugh. So they both start in the same year, 1960, but I have more data for GDP than I do for CO2. So I need to have the same number of data points for the scatter plot, and to do that, I'm going to trim off those extra ones. To do this trimming, I'll just ask for the years before 2012. And then I'll check that our data has the same number of values for both the GDP and the CO2 emissions. There we go. So we have 52 years worth of data for both. To make a scatter plot, we'll first call out the fig and the axis like we did before using the plot.subplots. Most of the rest should be fairly recognizable, except for the call to the method scatter to create a scatter plot with these two arrays. All right, now when I run this, what I get back is a pretty weak relationship. It looks like when GDP and CO2 emissions were climbing in the 60s, they tracked together. But after that, there doesn't seem to be much of a relationship at all. We could also test this using correlation. I'll use the correlation coefficient function in NumPy to get back the relationship between these two arrays. The main diagonal is each against itself, so we'd expect to see 1.0 there, or perfect correlation. But on the other diagonal, we see 0.077. That's a really weak correlation between these two indicators. So we just got started looking at these relationships, but if someone were to argue we need more CO2 production per capita to boost our economy, this initial data analysis would not support that claim. I have more ideas for what to do with this data set. Could we look at the relationship between CO2 emissions per capita and GDP for other countries? What about overall CO2 and GDP, minus the whole per capita component? This is an extremely rich data set, so I encourage you to continue to explore these on your own.